Okay, so here we're dealing with a statistics question, and there's three parts to it. The first part, we're asked to form a confidence interval, and then part B, we're asked to do a hypothesis test, and then finally part C, we're asked to find the p-value. Now, so for our hypothesis test, you could go about doing this two ways. The first way is to basically use your confidence interval in part A, and from that you're able to infer whether we should fail to reject the null hypothesis or if we should reject the null hypothesis. The second way is we basically find the test statistic, and based off of that value, whether it's greater than 1.96 or less than 1.96, we will fail to reject or reject the null hypothesis accordingly. So we'll go through part A first. So we're dealing with a mean sample, so a confidence interval for a mean sample. So the formula for that is x bar plus or minus e, the margin of error, where e is equal to 1.96 multiplied by sigma over root n. So here we have the sample mean is 90.45, so x bar is equal to 90.45, and then e is given by 1.96 multiplied by the standard deviation over the square root of the number of shoppers, which is 100 in this case. So we can put these two parts together, and then from this we can use our calculators to figure out the rest. So 90.45 minus 1.96 by 20.73 over root 100, you get 86.39 and 94.51. So if we were asked to interpret this result, we basically say that we can be 95% confident that the mean amount that people spend in shops is between 86.39 and 94.51 euros. Now, usually in exams, for the sake of the insert, it's always using a 95% confidence interval or 5% level of significance, but they could ask you for a 90% confidence interval or any other percentage really, but very rare for them to ask that, but you definitely need to know how to interchange between the confidence levels. Now, for part B, we're asked to conduct a hypothesis test to show that whether the mean amount is 94 euros or whether it's not 94 euros. So with every hypothesis test, we need to state the null hypothesis and also the alternative hypothesis. Now, the null hypothesis here is saying that mu, so the mean or the average, is 94 euros. And the alternative hypothesis is that the mean amount that shoppers spend is not 94 euros. So now we go ahead and conduct our hypothesis test. So one way we could do this is we basically take what we got in part A, here, our confidence interval, since it's related to a 95% confidence level, which also means it's really just the 5% level of significance. Using this, what we have to do is we have to see whether this 94 years lies within the interval or not. So we can clearly see that 94 does in fact lie within this interval because it's greater than 86.39 and also less than 94.51. So we can write that down. 94 is between confidence interval of 86.39 and 94.51. And then at the end, our conclusion from that, we basically say that we can fail to reject the null hypothesis. So that means the mean value that the shoppers are spending is 94 euros. Now, part C, we're asked to find the p-value, and we have to interpret what the p-value means in this context of the question. Now, a p-value is also a way to kind of conduct our hypothesis test, whether or not we should fail to reject or reject the null hypothesis. Now, we reject the null hypothesis when the p-value is less than 0.5 or whatever significance level is in the question. In this case, it's 5%. So we say that we would reject the null hypothesis if the p-value is less than it. But if it's greater than 0.05, we fail to reject the null hypothesis, basically meaning we accept what the null hypothesis is. Now, to calculate the p-value, we first need to calculate our t-statistic for the sample. So the t-statistic for the sample, we're going to use the formula in our log tables, which is given by x bar minus mu all over sigma over root n. So our x bar in this case is 94 minus the average is 90.45 all over sigma from the top is 20.73 all over root 100, and this gives us 1.71. Now, this is our test statistics. So going back to part B, we actually could have used this t-stat to basically state whether or not we should reject the null hypothesis. So if your t-statistic is between 1.96 and minus 1.96, so 1.96 is the z-value corresponding to a 95% confidence level or a 5% level of significance. If this value, here we have 1.71, lies within minus 1.96 and 1.96, we would also fail to reject the null hypothesis. So this is just a different way of doing a hypothesis test. So from this 1.71, we now need to go to our log tables and find out what the corresponding p-value is. So if we just take a look, 1.71, the corresponding proportion or percentage or decimal point, however you want to think of it, is 0.9564. Now that's not the value we want, because we want the 5% level of significance. What we're really talking about is the two tails here, the two little tails. So we need to subtract 1 from it also. 1 minus 0.9564, and we get 0.0436. Now, this 0.0436 actually only corresponds to one side of the tail, but whenever we're calculating for the p-value, we need to think of it in terms of both sides, because the extreme values, it doesn't just occur on one side of our normal distribution curve. It can be on the extreme left hand or the extreme right hand. So in other words, we need to multiply this value by 2 as well. So 2 times 0.0436, and we get 0.0872 or 8.72%. Now, what exactly is our p-value? So our p-value is basically the probability of more extreme values occurring if we fail to reject the null hypothesis. So in other words, there's an 8.72% chance of an extreme value occurring if we state that the mean value of shopper spending is 94 euros. So that's all you really need to write down. You can just write down p-value represents the probability of more extreme values occurring if we accept or fail to reject H0. So you can see this question, it's not too difficult. It really is just one long hypothesis test with a little confidence interval part at the start. And it's quite a nice question, relatively straightforward, nothing too difficult. Now, with regards to our p-value, I would say when doing a statistics question, don't calculate the p-value if you're not asked to. Just leave it alone, and if you're asked to calculate it and explain it, then you would do it.